Hello, hello. Good afternoon, everybody. Thank you, DMP Group. Thank you, Eastant, for the invitation to this sixth edition of the IDI. We are very happy and proud to be here today. And thanks also to give us the opportunity to give us a speech. I'm Vitali Ermanno from FAAM. FAAM is a... I will first introduce a little bit our company, and then I will try to give some clue on what is for us materials and design. So let me, please give me a few slides for our introduction of our company. FAAM belongs to a group, Seri Industrial, that is a listed company in Milan stock. And Seri Group is working in three main areas. The plastic, with the production of plastic components and recycling of the plastic. Lead, with recycling also of the lead and recycling battery, and finished product for the battery with the brand FAAM. So basically we are trying to close all the value chain and make a circular economy on the battery value chain. Our locations is mainly in Italy, and in China we have our factory in Yixing in the Wuxi district. The product that we have, especially here in China, is like you can see here. So we have 4 lines of batteries using the new technology, lithium technology, lithium iron technology. We produce batteries for forklift, for AGV, automatic guided vehicles, for tractors, or for example in the airport. And also we customize solution for energy storage, where the electricity need to be storage for example, for some backup. Yeah, this is some of our applications where we produce and our customer use our product. And this is a list of our customers. Before to discuss about the topic of this event, so design and material, I want to give a little introduction of the product that we have bring here, and we are showing up on the second floor. So it's a lithium battery, a module. We call it combi module. So this actually basically is produced in Italy, and in China here we design the pack, and we combine the module depending on the application. It's a very new, let's say, technology where the module is composed by many small modules. Each module has a standard, so we did this in order to standardize also the production, so to minimize and control as much as possible the cost. And then we can combine the small module into a big one, and then put the big one also in series in order to make a bigger and bigger pack, depends on the application that we need. This can be used in several applications, like also cars, basically. Some of our competitors actually are using already for automotive this kind of system. And but we are focused more on industrial application. Okay, now let's go the main topic of the events. So how the design and material influence the performance of a battery. So I'm not here today to give a lesson, but I take this picture that I think is quite clear and understandable. Every kind of product, cars or forklift, this is our main product, but also other kind of application where there is a battery, start with the electricity coming from the grid. So if you think that you get 100 of electricity, then I don't know how many know that actually in the lead acid, so traditional technology, only 92% goes to the charger. Then the charger, due to many inefficiencies, for example, of the net, of the cabling, or the product itself, only 70% goes to the battery, and then only 64%, this is an average numbers, but quite reliable, to the final application. So in this case, for the forklift. So how the design and the material influence this? Influence a lot. For example, if we change the material like lithium instead of lead, then we increase a lot the result of the usable energy. From 64, we can go up to 85. Why? Because the charger basically have similar efficiency. Anyway, now there is also a lot of improvement. So some battery chargers also can go up to, for example, 95 or 96%, reducing the inefficiency of the application. But then there is a big step up on the product, so on the lithium technology. The lithium technology can reach up to 93 or even more. What FAAM is doing is find and make the best research on development for material, software, battery management to reach the highest percentage as possible. Anyway, there still is an inefficiency when the electricity goes to the application. Okay, this is basically a very general concept, but I put it simple, and I think that our company try to increase the efficiency in order to, again, to increase the usable energy. I will conclude the presentation giving you some pictures in order to also give you some idea. This is a lead bar. So in China here we produce also lead acid batteries. So material, design and material. Material is very important. For example, there are so many kind of lead, so many kind of refined lead, of pure accuracy. So as much as the lead, the material is pure, as higher is the efficiency of the battery, because for example, the internal resistance of the battery is lower. So we used to buy, for example, the 99.99% pure lead in order to increase the efficiency. Of course, if you buy a higher quality product, material, your product need to be has a higher cost. So that means when you buy cheap things, something will it means something. Sooner or later you will find it. Designing the product is also very important. How we design the modules. So it's very important the design of the cable, of the connector, everything to make the internal resistance and efficiency of the battery as better as possible. I put this is one of the latest products that we designed. We started this year, and now with the lithium technology increased a lot the technology level. So we have a team that is able to design from the box to the cabling all by ourselves. And you can imagine that in a battery, in a lithium battery, where there are maybe thousands of cabling, it's very important how the design of the system and the battery management is done. So also the attention to the details of the cabling is very important. Last picture is regarding the board. So also the battery management is another very important point of the design and the efficiency. The board and the battery management is designed by ourselves in Italy, and it helps and increase the energy efficiency of the battery. That's our motto, that's our philosophy, energy saving battery. So the design and the material for us means make the battery with the best energy saving. Thanks a lot. If you like, follow us on WeChat, and I wish everybody and to the event good success.
Thank you, Ermanno. I was wondering, I just saw the different choice of materials have different effects on eventually the battery and the use of the machine. But I was wondering, there still is a trade-off with the percentage that you can use, even if you use the best materials. Is there, I think in the last slide, it's like 84% that you can use, even if you use the best materials. I was wondering, is there materials that you can use to get perhaps 95 or 100% actual use in the machine, or is that just impossible from what we can do right now?
According to my knowledge, the best result that we can have right now, I'm not speaking about FAAM, but in general in the market, is something near around 98%.
So that's the best of the best.
Yes. So if you use the best material, the best design, best technology, with a higher cost, of course.
I was just going to say, the cost surely go up.
Is the best result that you can reach.
Oh,
so,
thank you.
But it's pretty high. I mean, no, it's quite close to 100. So
I mean, 100 is next to nearly impossible to get from that.
Exactly.
I understand. Okay, just if we can open the floor for maybe other questions. Matteo here.
I always have one question, since you are producing the batteries. Also, even we know for a long time. Now we know, like for the new energy cars, we are all using, every vehicle is using the lithium battery. And how do you see the future of the use of lithium battery? You see solid, or there is any replaceable kind of materials can put in place of lithium to be used as for batteries? Thank you.
The answer to this question is quite difficult, and I also used to say that what we say today maybe is totally wrong in a week, because the technology development is very fast. Nowadays, the best solution in terms of performance, efficiency, and cost is lithium iron phosphate for many of our automotive cars, but also lithium nickel manganese cobalt. So these two. The two kind of chemistry have advantage and disadvantage. Some use nickel manganese cobalt, some others prefer to use lithium iron phosphate. The future is solid state. That's what I've learned and understood from several producers. So it means that the batteries, the lithium cells is not in a liquid state, but solid, it means higher efficiency, higher performance, and higher reliability, higher safety. But right now, as far as I know, this kind of technology is still a little bit far from the mass production. Maybe it needs kind of 10 years to be really marketable. In a longer future, there is a debate on hydrogen, for example. For example, could be one of the next also fuel. But personally, I believe hydrogen is a good for ships, big ships. So big, heavy usage, truck, train. Yeah, that's a more feasible, a more reliable application. But for automotive and smaller application, I believe that the batteries and the lithium, iron, or some other maybe chemistry, solid state is more reliable for the future. Thank you.
One more question, I'm sorry, Ermanno.
Thank you. Which is follow up this about cars and battery. Exist or will exist the battery that you never throw away? Because you know, like after a few users, they say, okay, this you should change it, and this may create a lot of waste. So the question is, beside the material, the technology that we say this is going to last 100 years. Isn't somebody plan, for example, Tesla or NIO, this big company with a lot of money, they are working in this direction?
Probably yes, I'm not sure, but in my opinion, no, there is no lasting forever battery. So what for sure we can work on also at FAAM as a producer is to extend as much as possible the life of the battery also after the first life. For example, the car used the battery for 10 years. And then this is the first life. And then we have a second life used for standby application. Because don't need, for example, a very strong power for the battery, but you need a more stable and even lower capacity is okay. So you extend another 20 years for another application. And then after this second life, maybe you have a third life. It means it will be kind of recycling, and can be almost close to 100% reused. So in a way, you can also say, yes, this battery is used forever, because when it's dead, you recycle and then start again. So it's a kind of, but I don't think there is a solution to say one product to last for 100 years. It will die, and then you maybe recycle it.
Thank you one more time, Mr. Ermanno Vitali.
Thanks again.